talk about sort of like the steps that we need to get solve this problem. So one of the things that we said that we need to find was the midpoints. So the midpoints of how many chords? 2. You can do all 3 if you want, but all we need is the minimum of 2. What else are we looking for then? Okay, why do we need the slope of the 2? Sorry, say that again? So that you can plug it into y equals. Okay, so you're close. We don't necessarily need the equation of a chord, right? But what is it that we want the equations of? Yeah. So the third thing that we need is the equations of the perpendicular bisector. And that's why we get the slope of our chords, right? Because the slope of our chords, well, the bisector is going to intersect at 90 degrees. So we know that relationship between slopes is going to be the negative reciprocal. Okay, so I drew a little diagram, just plotting our 3 points to the best of my ability, drawing a perfect circle around those 3 that captures those 3 points. Okay, I have technology; I can do the perfect circle. But even if you roughly do it, you get a rough idea of where your circle is and hopefully where the center is. So that in the end, if you say your point is right here, well, is that the center of your circle? Doesn't look like it. Even if it's like you said it was like right here, does that look like it's the center of the circle? No. So at least this gives you a visual of whether you're close or not. So let's calculate the midpoints. So I'm going to use chord AB and chord BC. Those are the 2 chords I'm using. Okay? If you use AC, you can do that as well. Unfortunately, you won't see the math behind that.
Wait, of AB?
Yeah, so first thing I want is the midpoint of AB. So I get x1 plus x2 over 2, y1 plus y2 over 2. So here I get 0 plus 1 over 2 and negative 4 plus 1 over 2. So that gives me 1/2 and negative 3 over 2, or negative 1/2. So as to plot that, so it's roughly around right negative half, so roughly around there. That looks about right. Okay. So a nice thing about the visual is we know that we're getting somewhere close. So the midpoint of BC is x1 plus x2 over 2, and y1 plus y2 over 2. So that gives me 7 over 2 and 1/2. So basically 3 1/2 and 1/2. Go back to my picture, I plotted it. It's about 3 1/2 and 1/2. So roughly around there, pretty close. So it looks like I'm in, at least I got my midpoints kind of correct. So again, what we want is, just going back away from the math, we want 2 perpendicular lines. So here's a green one. There we go. So that's a right angle. And then the idea is if I drew another one through the other chord, somewhere where the green and blue lines intersect, that's somewhere around where my center of the circle is. Okay, so we got a midpoints. But what do we have here? What do we see? 2 lines intersecting, right? Well, how do we find the intersection of 2 lines? How do we find the intersection of 2 lines? Well, before we even get there, what do we need? Well, we got the midpoint, but we have 2 lines. In that first unit, when we did solving linear systems, what did I have to give you? More than just the slope.
equation.
Yeah, you need the equations, right? Solving for two equations, right? So we need the equation of the blue line and the green line. That's what the number 3, right? But in order to get the equations, what do we need for each part of the equation? Slope and y-intercept. So here, starting a new page, I calculated the midpoints. So here I have the green line that looks something like this. The blue line. So we have the green line and the blue line. So let's calculate the equations of these. I'm working off of the midpoints. I want the equation of the green line first. So y is equal to mx plus b. Well, do I know the slope? How do I know the slope? Good. So what Mo is saying is that because there's a 90-degree angle to that chord, we figure out the slope to that chord, take the negative reciprocal, we get the slope of our green line. So on the side here, I need the slope of BC. I need the slope of that chord, which is delta y over delta x is equal to 1 minus 0 over 1 minus 6 gives me 1 over negative 5, right, or negative 1/5. So watch my notation here, because some of you, I see you doing this. Oh, I know what you're trying to say. Well, I want the negative reciprocal of that. And you go, well, that's equal to 5. Okay, that's not mathematically correct. Negative 1/5 is not equal to 5. Okay, so what you want to do is the slope that's perpendicular to this is 5. Okay, so that's how we communicate that. So here we go back into our equation, and we say, well, we're working with y is equal to 5x plus b. Okay, so now at least we've got the slope of that green line, right? By getting the slope of that chord BC. Is there a question, Jake? So 5 was the negative reciprocal of negative 1/5. And that's why I put it down here is the slope that's perpendicular to BC. Oh, sorry, this is a 5. Well, how do I solve for B now? Plug in what? Which midpoint? Sorry? Yeah, BC, like, because we're calculating the equation of this green line here, we need a point on that line. So A, B, and C, they're not on that line. We can't use it. This is why we need this visual. This is the only point that's on that line. So that maps to this point over here. So that's what's telling us is when x is 3.5, y is 0.5. So 0.5 is equal to 5 times 3.5 gives me 16 and a half? 17 and a half? Plus B? And so now how to isolate for B? Yeah, so subtract 17.5 from both sides. So B is equal to negative 17. So my equation for my green line is y is equal to 5x minus 17. So we have one equation. Right? Now we just need the equation of the blue line.
Should do this on Chrome.
So y is equal to mx plus b. So this is our equation of blue line. Same thing, right? How do we get the slope? How do we get the y-intercept? So how do we get the slope of the blue line? How do we get the slope of that blue line? Right? So we need that slope of AB. Like the line that is crossing, the line that is cutting in half is AB, and we know it cuts that at 90 degrees. Because we have 2 points on that line, we can figure out its slope. Right? So here we're going to calculate the slope over here of AB delta y over delta x. So here we got 1 minus -4 over 1 minus 0, which gives me 5 over 1, which is equal to 5. So the slope of the chord AB is just 5. Well, what's the slope perpendicular to it then? Sorry? Yeah, -1/5. Right? And that's the slope that we want to plug into there. So here we get y is equal to -1/2, -1/5 x plus b. Again, so how are we going to solve for b this time?
For the how it's like y equals mx plus b, you got the m from the slope from the AB, right? Slope
The one that's
AB.
perpendicular to AB. I don't want the slope of AB because this gives me that green chord
You
here.
want the-
I want this one here, right?
Thank you. Okay.
So I want the one that's perpendicular to it,
Okay.
90 degrees. So we do the negative reciprocal of the
So
slope.
like if you wrote just like
Hmm?
MAB equals -1/5, like you have to add that.
Yeah, because you tell me, so MAB is the slope of AB.
We want the perpendicular.
But we want, so that's what that perpendicular is for, right? Perpendicular to AB is -1/5. So how do I solve for B now? How do I actually finish my equation? Audrey? Yeah, this is the only point that we have that goes through that line. If there's another one up there somewhere, we could use it, but this is the only one. So that's this point here. So that tells me that when x is 0.5, y is -1/2. So -1.5 is equal to, so what's 0.5 divided by 5?
Why is it divided?
What's what's 0.5 times 0.2? That should be 0.1?
Negative.
-0.1. So here I want to add 0.10 to both sides, so -1.5 plus 0.10 is equal to b. So b is equal to -1.4. So therefore the equation of my blue line is y is equal to -1/5 x minus 1.4, which is really 7/5. So you can actually do this question with fractions a little bit harder. So now we have our two equations. So how do we get the point of intersection then? How is it that we get the point of intersection of those two lines now? Katie?
They equal each other?
Two lines equal each other?
No, you like take the
Substitute y's.
Yeah, we have two methods, right? So I think you're saying we keep y is equal to this, y is equal to that, so you get those two things equal to each other. So you're doing substitution. I think that's what you're trying to say.
Yeah.
Yes? So basically what we're going to do is I'm going to take this equation, y, 5x minus 17. I know that y is equal to this as well. So I'm going to substitute that in for y. So I get minus 1/5 x minus 7/5 is equal to 5x minus 17. Right? And that's what basically what Katie is saying, those two things kind of equal each other. Because we had simple equations that y equals something. So I want to isolate for x. So here I will subtract 5x. And then negative 17 plus 7/5. So this gives me negative 1/5 minus 1/5 gives me negative 26x over 5. Oh, sorry, I left out the x here.
oh,
So So again, negative 1/5 x, that stayed. I'm just subtracting 5x on both sides,
And then adding.
and then adding 7/5 on both sides. So which is negative 17 times 5, 85. Plus 7 over 5. So negative 26x over 5 is equal to 85. Minus 7 gives me negative 78 over 5. Multiply both sides by 5. Negative 26x is equal to negative 78. You divide both sides by negative 26. You get x equals 3. So a lot of work just to get an x coordinate. How do we get a y coordinate? Well, I'll take one of my equations. Y is equal to 5x minus 17. So 5 times 3 minus 17. So y is equal to 15 minus 17. Y is equal to negative 2.
20 marks.
So finally, that's our center of our circle. Right? So x coordinate 3, y coordinate negative 2, because that's where those two lines intersect. Any questions on this process? I know it's lengthy. But what I like about this question is it forces you to use midpoint. Forces you to find right angle bisectors. Makes you force you to solve two linear equations. What's the last thing I didn't get you to do? Length. So a concluding question could have been, or I could have started off saying, what is the length of the radius
No thanks.
Yes.
of this circle?
I love doing that.
So in other words, I could have went back to this question and said, instead of finding the center, I could have said, what is the length of the radius of a circle that goes around these points? Well, what did we do differently? Nothing. You still need to find the center of the circle.
What is the
Right?
area of the circle?
Well, once you find the center of a circle, what do you do with it?
Yo, I feel like such a math whiz.
How do you get the length? Once I got the center of the circle, how do I get the length of my radius?
You just go length of one of the points in the.
Well, length of my center to where? Yeah, to any of those 3 points. And that is the length of my radius. So the answer is, therefore, the center.
Fail the
Yes.
exam, I better do.
If we go back to our diagram,
This is so fun.
negative 3 comma negative 2 puts me right here. That looks about right. At least I'm not way out of that circle. So the nice thing about the warm-up is, yes, it took a lot of time, but I got you to practice just using tools that we have. So what do? Practice calculating in midpoint. Then we practice calculating slopes. And we saw that we had to take the negative reciprocal of those slopes to get that right angle. Then we had to come up with 2 equations based on those 2 right slopes and the points. Then we solve a linear system just to get our center. So for the last 20 minutes, what we're going to do is just start investigating the equation of a circle. Okay? Now, all circles that we're going to talk about, in terms of equation of a circle, is going to be centered around the origin. In other words, the center of the circle is at the origin. So that last question, I would never ask you what's the equation of that circle. Why? That warm-up question that we did, we had that circle, I would never ask you what the equation of that circle is. Why not?
Because there is no equation.
Yeah, because the center of the circle is not at the origin, right? So when we talk about equations of circles for this unit, it has to be at the origin, right? So we're going to start off with just this equation, x squared plus y squared is equal to 9. And we're just going to simply fill some table of values. Okay, so when x is 0, what's the value of y?
How'd you know?
Well, when x is 0, so when I plug in 0 into this equation, what are my possible values for y? So when x is 0,
Fine.
so when x is 0, what are my possible values for y?
3.
3.
Yeah, it's 3. Right? So basically it's y squared is equal to 9 because the x disappears. So we want y by itself, so we take the square root of 9. So basically we would have y squared is equal to 9, right? Because x is 0. So how do we solve for y? We take square root. So we get 3 and we get negative 3. Because when we take a square root number, we get positive and negative, right? So we just take that and we're going to plot it. 0, 3 and 0, negative 3 right there. But what happens when y is 0? What are my possible values for x?
Oh my god.
3 and negative 3. Same thing applies, right? So when y is 0, we just get x squared is equal to 9. Square root both sides, x is plus or minus. So we're going to plot those two. So negative 3, 0, which is right around here, and 3, 0 plus me there. Now we get something a little bit more tricky. When x is 1, what are my values for y?
8. Square root.
I heard 8. I heard square root of 8.
That's like a laser.
Well, when x is 1, what's x squared? 1. Well, we want to isolate y squared, so 9 minus 1, so we got 8.
8, yeah.
But then we need to take the square root of that, right?
Yep.
So what's the square root of 8? Somebody do that on the calculator for me? 2.82, I think.
2.8284. 2.828.
So 2.82. Positive and negative. So we'll plot that. Well, we're going to ballpark it because we can't be exact. So when x is 1, we get roughly around right here. And roughly around right here. So those are my 2 points there. What happens when y is 1?
Same thing.
Same thing, but now my x coordinates are those values. So I get 2.82 and negative 2.82. And again, I'm going to plot those. So when y is 1, we get 2.82, which is roughly around right here. And negative, which is roughly around right here. So around there. So finally, if it's x is negative 1, what's my value possible value is y? Well, what's negative 1 squared? Well, it's still 1. So we subtract 1 from both sides. We get 9 minus 1 is 8. So it's the same numbers again, right? So we get 2.82 and negative 2.82. I'm going to plot that. So x is negative 1. I'm going to have a point right here and a point right around here. And finally, when y is negative 1,
Same thing.
what are my values for x? Same thing. So hopefully we're starting to see a little connection there between our x values and our y values. But more importantly, as we're plotting this, negative 1, so we get 2.82 here, negative 2.82, what are you starting to see?
Oh, we see a square. You're so funny.
Hopefully you're starting to see a circle
This math looks like a cookie.
or a donut. So now that we have those dots and those points, we have a circle. What's the radius of our circle here? Well, how'd you say that so fast? You didn't do any calculations. Well, the center is 0. We just got 3 units. All right. Can you say that a little bit more like a teacher-like voice? Or monotonic? Right. We just see that there's 3 units there. Right. So the radius here is 3.
Oh, hold up. I missed that.
So we're just looking for the radius. Right. What's the radius of that circle? And we're seeing that it's 3 units. Well, what's the radius of What's the length of that radius? 3. So this one is 3 here. But what are my values? What are my values here?
3, 1.
This is 1
Oh, that's
and root 8.
Wait, where'd you get the
Well, root 8 is 2.82.
Uh-huh.
Square root of 8 is 2.82, right? Well, what's another way I can calculate the length of this radius? Yeah, Pythagorean theorem, right? Which is x squared. So I just take my x value squared, take my y value squared. What do I get?
But isn't the radius the same all around?
In this case, it's always going to be 3. But I can calculate that radius with any point on my circle, right? By just taking my x value, squaring it, and my y value, squaring it, and then taking the square root. But we have this equation here, right? Well, here x squared is 1, and with y is square root of 8, squared is equal to r squared. So here we got 1 plus 8 is equal to r squared, which just gives us 9. So therefore, r is equal to 3. And we kind of knew that going in. But this is the important part right here. That is the equation of our circle. X squared plus y squared is equal to r squared. That simply defines. So in other words, if we have the equation of this circle, what's the radius going to be? If I have x squared plus y squared is equal to 25. What's the radius of my circle going to be? 5. That's all we need to know for this unit, or for this lesson. Radius squared. So it's always the radius squared, r squared. So in this equation, x squared plus y squared is equal to 16. What's my radius? 4. Well, what are my x-intercepts? Adrian? Yeah, so we have 4, 0 and negative 4, 0. What are the y-intercepts?
0, 4.
Yeah, I mean, this is almost going to be not interesting.
Wait, do you just assume that it's
Well, because my radius is 4,
Wait,
and this is the
no.
equation of a circle, it's going to be the same length all the way around.
oh, so it's just whatever the square, I mean, whatever the radius is.
Yeah.
And the radius is always the square root of that number?
The equation of a circle, yes. So we got x squared plus y squared equals r squared. So that's why we say r squared, because it's actually the radius. The length of a radius squared. That's the equation of that circle. So this is the equation of a circle right here.
So we just did the square root of 16?
So in this question, x-intercepts are 7 and negative 7. What's the radius? Let's do the first thing. What's the radius? Audrey? Yeah, 7.
Yo, easy, easy.
Okay. So I'm going to do the rest of the table really quickly because it seems like we're getting the hang of it. The x-intercepts of, well, first of all, let's do the radius. So this one is just 10. And negative 10, comma
Wait, how'd
0.
you get 49?
Well, 7 squared
Okay.
is 49. So here this equation is x squared plus y squared is equal to 100. This one is the easiest one involved because it's actually given the radius. So x squared plus y squared is equal to 64. The x-intercepts are 8, comma 0. And negative 8, comma 0. The y-intercepts are 0, comma 8 and 0, comma negative 8. Okay. So again, doing this table just hopefully just conceptualizing what it is that we see with the circle, especially when it's around the origin. So the equation of a circle in center is 0, 0, and radius r. Well, we just talked about it. Okay. So that's the general equation of a circle around the origin. X squared plus y squared equals r squared. So determine the equation of a circle with a diameter of 7 centimeters. We're assuming a course around the origin. Center around the origin. So what's the equation of that circle? How can we get the equation of that circle? Well, how can we just start off with? What's the equation of a general circle? Feeling? Generally, what's the equation of a circle? We just did it. We just wrote it. X squared plus y squared is equal to r squared. Right? Well, what's r?
Half a second.
Half of the diameter, right? So here d is equal to 7. Well, r is equal to d over 2, which is 7 over 2, which is 3.5. Right? So we just get x squared plus y squared equal to 3.5 squared. Plug that in your calculators. That's it.
But that's it.
That's it. I know.
So you'd rather have it be in decimals than fractions?
In this case, yeah, it's fine. Because we're doing the square, it might be easier that way.
But for all the median stuff, I mean, yeah, like the midpoint stuff and coordinates, you want it to be fractions.
Midpoints, coordinates you can use as decimals. But what's the advantage of having slopes as fractions? Well, what's the advantage of having slopes as fractions?
Oh, the rise over run thing. You can use the plot. You can draw a line.
Well, you could draw a line, but what's the other advantage? What did we just do recently with slopes? Sorry? Yeah, perpendicular bisector. What do we need to do to get the perpendicular bisector? Yeah, so we need the reciprocal. So if we have a fraction already, it's easy to do the reciprocal of a fraction. As opposed to have a decimal. Well, what's the reciprocal of 3.6? Yeah, you can't tell me, can you, that fast? What's the reciprocal of 7 over 3? 0 over 7. So that's why there's some advantages to keeping some things in a fraction. Okay, so another key thing that we need to understand is question like number 2. So given a circle with center 0, 0, right, our origin, and it passes through 6, -9, right, so I have a circle that passes through this point, so you can always try and visualize it if you want. I guess we can use this grid down here.
Oh.
So I have a point 6, -9. Basically, we have a circle that goes around this, that hits that point. So we need to determine if the point 6, 4. We need to know if this point is that inside, outside, or on our circle. How can we determine that? What equation? Plug in the course to the radius of the circle. I'm not sure if I quite understand.
Or
that.
the equation of the circle.
Okay, well, so we can work with the equation of a circle. I think Rob wants to tell us something.
If the center is 0, 0, then the point 6, -9 is going to be the same on all of the corners of the grid, but just with other negative. It's sort of hard to explain. It'd be like 6, -9, and then like.
Well, but we know
6,
6.
9.
We just know that 6, 9 is on our circle, but we don't know anything about 6 and 4.
Well, you can draw it.
We could draw it, but
Visual-
sometimes we
visually
can't tell
see.
exactly for sure, right? Well,
But don't we know the radius?
well, we can figure out the radius.
Because it's the center is at 0, 0, and if the coordinate is 6, then isn't the radius 6?
So what's the radius of a circle that goes through that? No. If I go back to our diagram, that radius is right here, right? We need the length of this. So can we just now apply the length formula? Right? So the radius is really the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, this is just the square root of, well, what's x2 here? 6 minus 0 plus negative 9 minus 0 squared. Well, what's 6 minus 0? What's negative 9 minus 0? When we do this for a circle, what's x2 and y2 always going to be? X2 and y2, what is it always going to be? What are these two values always going to be? Or sorry, x1, y1 in this case. The origin is always going to be 0, 0. So really, we just have r is equal to the square root of x squared plus y squared. In other words, even if we took for equation of our circle, we isolate for r. So we just plug in our x and y values that we have on the point. So 6 squared plus negative 9 squared, square root of that. So we have square root of 36 plus 81, which is 117.
Wait, so
Right.
we don't have to do the length?
Well, this is the length formula. We just said one coordinate is always going to be 0, 0.
Oh.
Because it's the origin, exactly. Well, what's the length of a segment from 6, 4 to the origin? So how can we calculate the length from 6.4 to the origin? It's the same thing, right? So here, ran out of space. I'll do it in green. So here I want the distance. What was the coordinates again? 6 and 4? So that's what, 36 plus 16? Well, we know the distance from the center of origin to that point is square root of 52. So is it shorter or longer than the radius? It's shorter, right? So does it have to be inside, outside the circle then? It's inside. So that's how we can quickly check if a point inside, outside, or circle. Just calculate the distance from the origin. So if it's less than the radius, it's inside. What happens if it's greater than the radius? Outside. What happens if it's the same length as the radius?
On the outside, I don't know.
So that's how you go off in algebra to show if a point's inside, outside, or circle. Finish this package, which I think is a couple more questions. So that's number 1 BD, number 2 ACE,
Oh, okay.
and number 4 BDF.